The first woman in Europe to earn a doctorate degree. The discoverer of two new elements. The first woman to receive a Nobel Prize, and the first person to receive two Nobel Prizes. The first woman to teach at Sorbonne University. The first woman to receive the American College of Radiology Gold Medal. Who was it? Marie Curie. Marie Curie's discoveries in the late 1800s and early 1900s, especially with radioactivity in polonium and radium, which both were discovered in 1898, created a turning point in history to make significant advancements in different fields such as science, medicine, and warfare that benefited or saved a countless number of lives, and she was an early female scientist whose accomplishments encouraged other women to work in this field as well, with about 1/3 of the scientists being women today. Marie Salomea Sklodowska-Curie was born on November 7, 1867 in Warsaw, Poland. Mary became the top student in her secondary education and moved to Paris at age 24 to study physics at Sorbonne University. She studied hard and earned her degrees in physics and math. Later, she meets her husband, Pierre Curie. They married each other, and while working on their scientific discoveries, they started a family with two children, Eve and Irene. The first reason on how Marie Curie's discoveries was a turning point in history was how it affected the different fields, science, medicine, and warfare. Science. It all started with Henry Becquerel. The rays that were used in the newly discovered X-rays by Wilhelm Röntgen inspired him to study them. In his experiment, he investigated how uranium made photographic plates react. The reaction of the photographic plates showed that uranium released the radiation that caused it. Marie Curie coined that property the term radioactivity. She then set out to explore more about this new property. She replicated the experiment multiple times and confirmed that uranium acts this way in any form. She found out that the radioactivity came from within the structure of the atom. With this, she documented her own thesis in 1903 in research on radioactive substances. Radioactivity overall is the energy released by the decay of unstable atomic nuclei. This energy came from particles within the atom. Previously, it was believed that atoms were inseparable and were the smallest unit of all matter. But the new discovery that particles, such as alphas, were being emitted by the atom meant that there were smaller parts within the atom that in fact could be separated. Marie Curie's findings of radioactivity originating within the atom changed scientists' understanding of the atom itself and showed that uranium was not the only radioactive substance. Upon the discovery of radioactivity, Marie Curie studied pitchblende, a uranium ore which was more radioactive than pure uranium itself. This pitchblende was made up of many different elements, and the Curies wanted to separate them to see where the radioactivity originated from here. From some chemical processes, she found the existence of two new radioactive elements in 1898. First, in July, she discovered polonium, which was 400 times more radioactive than uranium, and named it after her home country, Poland. Then in December, she discovered radium, which was 1,000,000 times more radioactive than uranium. These two elements would go on the periodic table with atomic numbers 84 and 88 respectively. But this wasn't enough. She needed to prove that the two elements actually existed. She set out to isolate polonium and radium and also find more about their properties. It took 3 years to isolate radium. Polonium could not be isolated due to its short half-life of 138 days, whereas radium has a half-life of around 1,600 years. Marie and Pierre's last name, Curie, was later used as a unit to measure radioactivity. This shows the significance of their work and their importance to the scientific community as they created a turning point in history for science. Medicine. Cancer has been a frightening disease to the human race since the beginning. The malignant cells killed the patient and there was no real treatment. But this changed after Marie Curie's work. There was a turning point in history for medicine. Early on in 1904, brachytherapy was introduced as a treatment. It used radium as they acted similar to X-rays, and Marie Curie discovered that it affected cancerous cells more than normal cells. The rays were focused near the tumor. However, the different situations where the tumors could be treated were limited, as this new treatment required the tumors to be on the surface of the body. It was also discovered that radium decayed into radon. Radon gas would then be used as another alternative way of treating cancer, as radium was expensive and rare. Radiation therapy continued to evolve and save many lives. Along with radium being used in cancer treatment, it was used in many other products for the regular people. These products were mostly promoted for the luminosity that came from the radium in it. Some products included makeup, paint, toothpaste, water, and even butter. Advertisements made people believe that radium was good for you. Some of the products didn't actually contain radium and were just there to increase their demand. But while the others did contain it, the users had to suffer its consequences. In 1910, women used to work in factories to paint dial watches. The paint contained radium. To sharpen the brush to paint the dials on the watch, the women were instructed to point them by sliding it across their lips. The radioactive paint would remain on their lips, and they didn't realize the dangers of it until they started developing tumors and dying years later. These women then rebelled as the radium girls and led to safety policies to be set into place for working environments and spread the awareness of the troubles of radioactivity. Marie Curie herself died from continuous exposure to radioactivity in her lab. First, she developed a double cataract and had trouble seeing. Perhaps radium has something to do with these troubles, but it cannot be affirmed with certainty. She needed assistance to do many things due to her illness. Eventually, she was diagnosed with aplastic pernicious anemia. Her bone marrow was damaged from the repetitive exposures to radiation. Warfare. During World War I, Marie Curie came up with radiological cars known as Petite Curies to bring X-ray units on the battlefield and treat wounded soldiers. The dial watches that the radium girls had painted were used by soldiers at war. The luminous radium allowed them to see in the dark and prevented enemies from seeing them. In World War II, polonium and other radioactive substances were used in the atomic bomb that was used to attack Nagasaki, Japan in 1945. It killed many people, but also ended the war, which created a turning point in history and kept lasting effects on the world. The second reason on how Marie Curie's discoveries was a turning point in history was how her achievements as a woman encouraged other women to work in the field of science as well. Marie Curie was an extraordinary woman who went through many hardships to get to her level of respect today. Women had less rights than men in her day, and it was hard for them to go ahead. Mary was not able to attend her local university as they did not accept women. However, she was able to attend and become the first woman to receive a doctorate degree in science at Sorbonne University in Paris. And after the discovery of polonium and radium, she won the Nobel Prize for Physics in 1903 with her husband and Henri Becquerel. After the unfortunate death of Pierre Curie in 1906, she would replace his job as a lecturer at Sorbonne, becoming the first woman to teach there. However, even with all her work, she was rejected to be in the French Academy of Sciences as she was a woman. Despite these troubles, she went on ahead to win the Nobel Prize for Chemistry in 1911 for isolating pure radium. Marie Curie was the first woman to receive not only one, but 2 Nobel Prizes. Later, on her trip to the US, she became the first woman to receive the American College of Radiology Gold Medal. This influenced many other women as they built on to her work. Her daughters also followed her. Irene continued to pursue her mother's career, and her work also earned her the Nobel Prize for Chemistry in 1935. Eve became well known for writing a biography of her mother. The first woman who did get a seat at the French Academy of Sciences was Marguerite Perry, who was a student of Marie Curie. The next woman to receive the Nobel Prize of Physics after Marie Curie was Maria Goeppert-Mayer in 1963. Rosalind Sussman-Yalow states that Eve's book on Marie Curie encouraged her to become a scientist too, and she earned herself the Nobel Prize of Physiology in 1977. This was only the start. From the foundation that Marie Curie had set, many oncoming women scientists were yet to come. Women who pursued other fields in science besides radiology included Jane Goodall, Sally Ride, and many more. The population of women in science increased rapidly as their rights increased and more women started taking interest in that field. Today, 1/3 of the scientists are women. Marie Curie's discoveries in the late 1800s and early 1900s, especially with radioactivity in polonium and radium, which both were discovered in 1898, created a turning point in history to make significant advancements in different fields such as science, medicine, and warfare that benefited or saved a countless number of lives, and she was an early female scientist whose accomplishments encouraged other women to work in this field as well, with about 1/3 of the scientists being women today. Without her work, the elements polonium and radium may not have been discovered until much later. Similarly, the treatment of cancer may not have proceeded without her. Without her Petite Curies, wounded soldiers would not have been saved, and without the knowledge of radioactivity, the atomic bomb may not have been invented and World War II may have lasted longer. She truly created an incredible impact on the world.